Welcome to Tech Info with Narsimha channel. Don't skip the video, see to the end. And like, share, comment, and subscribe my channel and press bell icon to get my latest video notification.
Hi friends, so in this video we're going to analyze a simply supported beam with UDL. So in the last video we have made a simply supported beam with a point load analysis. So in this video we're going to deal with the UDL concept. For that, go for the new project and give the name as 3 as its wish and location, and length units as meters as per IS standards. So force units as kilonewtons, and next and finish. So a page is opened here. Wait for some time. The node page will be visible here. So you can see node page has been opened here. So delete, remove it. And first of all you have to create a beam. For that beam, first of all we have to create a node. For that, from here node column you have to just 0, enter, and I'm taking a 5-meter beam. So after we have getting two nodes here. So first of all we have to view from plus z, then we can say straight, then after we have to add a beam. So from this point to this point we have to draw a line, then our beam is created successfully. So now we have to add loads and supports. For that we have to go to the general and support. So first of all we have to create a support here. I'm assuming as a pin support, add. So from here and use the cursor and highlight this in, so assign, yes. So we have assigned a pin supports here, and after that we have to add a loads. So for the load case details, add. So I'm here, we are assuming a UDL. So add, close. Then after going to the UDL you have to add, so member load, uniform force. So first of all uniform force we are assuming is minus 150. Downwards is acting for global Y. Add, close. So here it's showing the question mark because we didn't add any load on these beam. So for that, first click this and using the cursor of the mouse highlight the beam like this and assign to selected beam. Assign, yes. We can see it's acting downwards, but it is not visible properly. For that we have to go for here and loads. You can see the UDL is acting 150 kilonewton downwards. UDL is acting in a simply supported beam. So after that we have to give the property define rectangle. Then I'm assuming ZT as 0.23 and YD as 0.38. So it's your wish, you can add anything here. It's just dimensions of the rectangle material, and also you have to choose a material here. Add, close. After that you have to re-highlight the beam and just assign to selected beam, assign. Yes, you can see one R1 value is here, that way we assigned this. So and after that we have to go to the command button and analysis, perform analysis, no print. Then after we have to analyze, so control F5 we can enter by using keyboard, save. Then it's analyzing, it's showing whether any error is there or not, but here there is no error, only showing one warning. So we didn't neglect the warnings, so we will only see the errors here. So errors are 0, then we have to go to post processing mode, done. So in this, go to the range and OK. So you can see the beam here. So you can, by using control button and scrolling from the mouse, you can see the downward action of the simple UDL. So and also you can see the bending moment and shear force diagram also. So you can see this is a bending Z movement, bending moment of the simply supported beam with a UDL constant of minus 150 kilonewton downward direction. You can see this is the maximum. We can see the maximum bending moment here. So the maximum bending moment at the Z direction is minus 468.750 is the maximum, and also we can see the maximum shear force. So for seeing the shear force diagram, we have to remove the Z direction movement and we have to add the shear force. In Y direction you can see the shear force. So like this, the shear force is acting like this, and also you can see the shear force value is minus 375 on 335 upward and minus 375 downwards. So for seeing the results, we have to go to the results and results, view value, and beam analysis ends, maximum at midpoint, and we have to select all these here. So and also we can annotate, okay, close. We can see the 35 375.00 kilonewton upward direction, it's positive. It's downward direction minus 375.0 because of its downward direction. And also you can see the moment value is also minus 468. You can see the minus 468 value, its maximum value at middle, it's minus 46. And also you can see the axial force and also the torsion moments, shear force, and also you can see so many mu limit values. Also you can see the stresses here. These are the stresses occurring at the beam, and you can see the maximum stress and the profile stress. And also you can see the graphs here. You can see this is a beam of downward acting minus 150 kilonewton downwards. That's why it's going actions like this. And also this is the bending moment diagram. This is the shear force diagram. You can see here. And also you can see the forces. These are the major forces acting here. Maximum axial force, maximum bending moment is minus 468. Maximum shear force value also you can see here. So this is the analyzing of the simply supported beam with UDL. So if you really like the video, please subscribe to my channel and share to your friends for the further understanding. If you have any doubts, you can comment me in the comment section. I will definitely reply you all. Thank you, friends.
Thank you. Please like and share the video and subscribe my channel.